On February 20th, 1943, situated just north of the Kasserine Pass in Tunisia, the battlefield witnessed a phenomenon that official reports would never fully capture. That morning, German commanders watched in disbelief as American Sherman tanks executed complex maneuvers that defied every doctrine the Wehrmacht held regarding movement without visual signals. Through the blinding dust and obscuring smoke of the North African front, 5 Shermans, separated by broken terrain and lacking any direct line of sight, converged on German positions with a synchronization that appeared almost supernatural. There were no signal flags, no flares lighting the sky, and no dispatch riders frantically racing between vehicles. Yet, these machines moved as a single cohesive organism, with each crew covering the blind spots their comrades could not see. Conversely, inside German Panzer IVs equipped with FUG-5 radios, commanders struggled to hear their own company leaders through a wall of static that completely overwhelmed their amplitude modulation systems. These 10-watt German transmitters, considered state-of-the-art by 1930s standards, could barely penetrate a few hundred meters when the tanks were in motion, leaving most receivers silent and unable to call for aid. The Americans, however, were operating with a technology the Germans did not even know existed: frequency modulation radios installed in every single tank. This system boasted crystal-controlled precision and 25 watts of transmission power, offering a clarity that cut through the roar of engines and the chaos of battle like a knife through paper. 8,000 miles away from the assembly lines of Detroit, the most decisive technological advantage of World War II was finally revealing itself, not in the thickness of armor or the caliber of a gun, but in the invisible electromagnetic waves that connected every American tank crew in ways the Wehrmacht had never imagined possible. This transformation began on July 22, 1941, when the United States Army standardized the Signal Corps radio sets, specifically the SCR-508, SCR-528, and SCR-538, for use in all medium tanks. While German forces were sweeping through the Soviet Union, relying on tactics that necessitated radio links between command vehicles, American engineers at the Galvin Manufacturing Corporation, which would later become Motorola, were perfecting the frequency modulation technology that would soon render those German systems obsolete. The engineering team included Daniel E. Noble, who first conceived the application of FM technology for military vehicles, and Henryk Magnuski, the principal RF engineer who solved the immense technical challenges of installing sophisticated electronics within the harsh, vibrating environment of a tank. Their resulting creation weighed 181 pounds and effectively transformed every Sherman tank into a node within the world's first true battlefield network. The BC-604 transmitter generated 25 watts of power, which was 2.5 times the output of the German FUG-5. Operating in the 20.0 to 27.9 MHz frequency range, it provided 10 preset channels with crystal-controlled stability. Furthermore, the dual BC-603 receivers located in the SCR-508 allowed commanders to monitor multiple frequencies simultaneously, a capability that would prove absolutely decisive in the heat of combat. The true revolution, however, lay in frequency modulation itself. Edwin Armstrong's FM technology, which had been licensed to the military, completely eliminated the static and interference that plagued the older amplitude modulation systems. While German tank radios picked up every electrical discharge as deafening noise, American FM radios delivered clear voice communication even during the most intense artillery barrages. On November 8, 1942, Operation Torch brought American armor to the shores of North Africa. The 2nd Armored Division's tanks landed near Safi and Fadala equipped with SCR-508 radios that would immediately demonstrate their superiority over German communications. The Afrika Korps, despite being the Wehrmacht's most experienced armored force, operated under severe limitations. A standard German tank platoon of 5 vehicles typically included only 1 or 2 tanks with full FUG-5 transceivers capable of both transmitting and receiving. The remaining German tanks carried only FUG-2 receivers, meaning they could hear orders but were powerless to respond or report enemy positions. Consequently, German tank platoons functioned through a rigid hierarchy, where the platoon leader transmitted orders that subordinate tanks acknowledged through actions rather than words. If the command tanks, easily identified by their multiple antennas, were destroyed, the entire platoon lost coordination, a vulnerability that would prove catastrophic against American forces, where any tank could instantly assume command functions. The Battle of Kasserine Pass, fought from February 14th to the 24th, 1943, provided the first major demonstration of this American radio superiority. Although tactically a German victory, the engagement revealed capabilities that stunned Wehrmacht observers. During the confused fighting, scattered elements of the U.S. 1st Armored Division maintained coordination across 50 miles of the battlefield. Tank crews who had never met before coordinated complex attacks, warned each other of threats, and called for artillery support through crystal-clear FM communications. German signals intelligence units intercepted these American transmissions and noted their exceptional clarity and coordination. The 10th Panzer Division's intelligence section reported with concern that American units maintained communication at ranges where German radios produced nothing but static. Even more disturbing was the realization that every single American tank appeared capable of full transmission, rather than just the command vehicles. In contrast, the German FUG-5 radios, operating on amplitude modulation in the 27.0 to 33.3 MHz range, suffered from fundamental limitations. The 10-watt transmitter struggled to reach distances of 2 to 3 kilometers, even in ideal conditions, dropping to a mere few hundred meters when the vehicles were moving. Every spark plug firing, every electric motor, and every track movement generated interference that the AM systems simply could not filter out. By September 1943, American armor had arrived in Italy, entering mountainous terrain that should have, theoretically, negated their radio advantages. Instead, FM technology proved even more valuable in these rugged conditions that rendered German AM radios useless. The SCR-508's frequency modulation handled the multipath interference common in mountain valleys far better than amplitude modulation ever could, ensuring that the Allied communication network remained unbroken. During the advance toward Cassino, American armored units displayed a level of tactical coordination that completely baffled their German adversaries. While navigating rugged terrain where ridge lines blocked all visual contact and German equipment picked up nothing but static, American tank platoons executed precise, synchronized attacks. After-action reports from the 1st Armored Division confirmed that their crews routinely maintained cohesion over distances that German doctrine deemed impossible without direct line of sight. When Sherman tanks stormed the beaches of Normandy on June 6, 1944, their SCR-508 radios allowed for direct contact with naval fire support, a feat unmatched by enemy technology. Yet the subsequent fighting in the hedgerows exposed a fatal flaw. There was a complete inability for armor to communicate with the infantry, as the foot soldiers' SCR-300 sets operated between 40.0 and 48.0 MHz. This frequency band was entirely incompatible with the 20.0 to 27.9 MHz range utilized by the tanks. In the dense bocage, this technological disconnect turned deadly, allowing German infantry armed with Panzerfausts to ambush armor while nearby American troops stood by, helpless to shout a warning over the airwaves. However, American ingenuity bridged this gap within weeks by welding ammunition boxes to the tank exteriors to house EE-8 field telephones, wired directly into the internal intercom. By the launch of Operation Cobra in late July, this remarkably simple modification had fundamentally revolutionized cooperation between tanks and infantry. During the intense combat of Operation Cobra from July 25th to the 30th, 1944, the 2nd Armored Division under Major General Edward H. Brooks showcased the devastating potential of American radio superiority. By coordinating over 200 Sherman tanks through a sophisticated network, they achieved a level of battlefield control that led the defending Panzer Division to believe their enemy possessed a supernatural awareness. Threats identified by units miles away met with an instant response, while artillery strikes called in through tank radios rained down within minutes of a target being spotted. The situation on the other side of the front lines presented a stark contrast, as even Germany's premier armored division, Panzer Lehr, had been reduced to a state of abject communication poverty. In terrain where visibility rarely exceeded 100 meters, most German crews were forced to rely on archaic visual signals because their vehicles lacked radios entirely. Even the few units lucky enough to possess functioning equipment found their efforts thwarted by severe interference and limited range that made effective coordination impossible. This collapse was profoundly ironic, considering that Germany had actually pioneered the integration of wireless communication into armored warfare under the guidance of Heinz Guderian, the architect of Blitzkrieg. Since the 1920s, and emphatically in his 1937 book, Achtung, Panzer, Guderian had insisted that reliable radios were the backbone of rapid armored advances. He had successfully developed early systems, allowing officers to coordinate attacks, firmly establishing the doctrine that communication was as vital as firepower. Despite this doctrinal head start, by 1943, the German industrial base had failed to supply the equipment Guderian's strategy demanded. Production statistics from that year reveal a crippling crisis. While Germany manufactured approximately 5,700 medium tanks, they produced fewer than 2,000 FUG transceivers. With priority given to command vehicles and assault guns, the vast majority of regular tank units were sent into battle desperately short of essential communication gear. The situation was even more dire for Soviet forces, where the T-34, despite being the most heavily produced tank of the alliance, typically rolled into combat with no radio equipment whatsoever. Early in the war, this forced reliance on flag signals and rigid pre-battle planning, leading to catastrophic results against German maneuvers in 1941. Although Lend-Lease eventually provided some relief by equipping command tanks with American sets, like the SCR-508, only about 25% of Soviet tanks carried radios, even by the end of the war. While the Soviet Union struggled to equip a mere quarter of its fleet, the United States achieved a 100% deployment rate of sophisticated FM systems, a feat driven by the industrial might exemplified by Motorola's Chicago factory. Transforming from a civilian manufacturer of car radios to a military powerhouse required a complete retooling of their assembly lines. Engineers had to overcome unprecedented technical challenges to mass-produce precision electronics capable of surviving the battlefield. The complexity of the SCR-508 was staggering, with each unit comprised of 2,748 individual components, including hundreds of capacitors and resistors in the transmitter alone. Production skyrocketed from 3,800 units in 1942 to 24,000 in 1944, ensuring that every single one of the 49,324 Sherman tanks built received advanced radio equipment, a manufacturing miracle that no other nation could approach. Beyond sheer numbers, the technical superiority of the SCR-508 lay in its crystal-controlled frequency stability, which allowed crews to preset channels and maintain alignment even in the chaos of combat. In contrast to German FUG-5 radios, which used variable capacitor tuning that constantly drifted off frequency, the American system provided rock-solid reliability. Furthermore, its dual receiver configuration allowed commanders to monitor both the platoon and company networks simultaneously, ensuring that orders flowed instantly down the chain of command without losing situational awareness. Inside the tank, the integrated BC-606 intercom system, paired with throat microphones and noise-canceling headphones, allowed the entire crew to communicate threats clearly, whereas many German crews were forced to resort to shouting or physical touch. Even the power supply provided a distinct advantage. The American dynamotor system delivered stable, filtered energy that eliminated interference, while German radios, powered directly from the vehicle's electrical system, picked up every engine spark as static. Ultimately, this universal deployment of high-fidelity radio technology didn't just improve performance, it fundamentally transformed American armored doctrine. The entire efficacy of the American Combat Command structure, specifically its ability to organize flexible task forces for distinct missions, hinged upon the bedrock of reliable communication. Because U.S. commanders could confidently coordinate through compatible radio systems, they were able to assemble ad hoc battle groups from disparate units on the fly. This operational fluidity utterly perplexed German leadership, whose own organizational rigidity was dictated by the severe limitations of their communications technology. The disparity became glaringly apparent during the Battle of Ericourt in September 1944, where the 4th Armored Division clashed with multiple German panzer brigades fielding superior Panther tanks. Although the enemy held every conventional advantage regarding armor protection and raw firepower, the decisive factor ultimately proved to be American radio coordination. Every single Sherman tank possessed the capability to instantly broadcast enemy coordinates, allowing units to operate with a shared consciousness. Through this interconnected network, tank destroyers engaged targets they could not visually identify, guided solely by real-time data from the front lines. Simultaneously, artillery observers positioned in Sherman command tanks could summon devastating barrages within minutes, decimating enemy formations before they could deploy. Over a span of 3 weeks, the 4th Armored Division obliterated 281 German armored vehicles, while sustaining only 41 losses, a staggering 7-to-1 kill ratio that defied all technical specifications and expectations. Remarkably, throughout the conflict, German intelligence consistently failed to comprehend the true source of this superiority, attributing the seamless American coordination to intense drilling rather than technological innovation. A captured intelligence assessment from September 1944 noted that U.S. tank units displayed exceptional discipline, concluding that this result stemmed from extensive training and rigid communication procedures. This analysis completely overlooked the critical technological advantage that made such cohesion possible. Consequently, Wehrmacht tactics never evolved to counter American capabilities. They persisted in targeting vehicles they believed to be command tanks, based on antenna configurations, unaware that every Sherman could direct the battlefield response. Furthermore, they planned ambushes under the false assumption that U.S. units would lose cohesion once physically separated, failing to realize that radio contact preserved tactical unity regardless of visual isolation. By March 1945, as American forces neared the Rhine, this communication dominance reached its zenith, most famously demonstrated during the capture of the Remagen Bridge. When the 9th Armored Division discovered the Ludendorff Bridge was still intact, radio reports reached 1st Army headquarters within minutes, triggering an immediate strategic pivot. Within a single hour, divisions across the entire front were reorienting to exploit this fleeting opportunity, a speed of command that the enemy could not hope to match. In contrast, German forces relied on vulnerable telephone lines that American aircraft systematically destroyed, leaving them unable to react with comparable velocity. American radio networks facilitated the creation of an impenetrable defense around the bridgehead, allowing tank platoons from different battalions to integrate seamlessly and coordinate their fire. German counterattacks, arriving piecemeal due to widespread communication failures, was systematically dismantled and destroyed in detail. The culmination of this advantage occurred in April 1945, during the encirclement of the Ruhr Pocket, where armored columns from the 1st and 9th Armies orchestrated a complex double envelopment entirely through radio coordination. Inside the pocket, 325,000 German troops found themselves entrapped, a situation exacerbated by the total collapse of their own command infrastructure. American fighter bombers, guided by forward air controllers equipped with radios, systematically obliterated the remaining German communication nodes. Wehrmacht units rapidly lost contact with both their higher headquarters and neighboring forces, plunging them into chaos. Field Marshal Walter Model's final messages before the blackout reveal the desperate plight of the German army. No contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. Beyond the tactical metrics, radio superiority profoundly altered the psychological landscape of tank warfare, providing American crews with the reassurance that they were never truly alone, even when physically isolated. Conversely, German tank crews suffered from a profound sense of isolation. Unable to communicate effectively, they were reduced to fighting solitary battles within the larger engagement. Renowned panzer ace Otto Carius alluded to these challenges in his memoir, Tigers in the Mud. Though the strategic implications extended far beyond the struggles of individual commanders. The Third Army's rapid race across France was sustained by radio networks that maintained control over hundreds of miles, a capability Heinz Guderian, Inspector General of Armored Troops, eventually recognized. In a December 1944 memorandum, Guderian admitted that superior American coordination effectively negated the advantages in quality held by German tanks. Following Germany's surrender, evaluations by American technical intelligence teams confirmed what combat experience had already suggested. While German tanks often boasted superior armor and armament, their communications were catastrophically inferior. U.S. Army Technical Intelligence Report number 176 concluded that German equipment was approximately 5 years behind American systems, citing the absence of frequency modulation and poor electrical suppression as critical vulnerabilities. Notably, the Red Army reached similar conclusions, choosing to copy American radio designs for their post-war development, rather than utilizing captured German technology. The magnitude of this achievement is starkly illustrated by production and deployment statistics. While the United States produced over 50,000 units of the SCR 508, 528, and 538 radio series to equip a total production of 49,324 Sherman tanks, the German industry managed only approximately 6,000 FUG-5 transceivers. The American commitment was absolute. A 100% deployment rate, featuring crystal-controlled frequency stability of plus or minus 0.01% and a transmission power of 25 watts. This provided a moving range of 7 miles and a stationary range of 10 to 15 miles, creating a tactical network that the enemy simply could not replicate. When you examine the German production numbers, you find that medium-heavy tanks totaled approximately 12,000 units, yet their full transceiver deployment rate was only about 20%. These systems operated with a transmission power of 10 watts and a frequency stability of plus or minus 1%, which severely limited their effectiveness. Consequently, you would see a moving range of just 0.5 to 1 mile, increasing to only 2 to 3 miles when the vehicle was stationary. The contrast in communication effectiveness is even more striking when you consider that the average time for an American fire mission was merely 3 to 5 minutes, compared to a sluggish 15 to 30 minutes for a German mission. While American tanks achieved a coordination level of 100%, you will find that German tanks managed full communication in only 20% of their forces. It is clear that the radio superiority of Sherman tanks established the very principles that govern armored warfare today. If you look at modern main battle tanks, they carry communication suites that trace their lineage directly to the SCR-508. While these are now digital rather than analog, they remain fundamentally based on the same concepts of universal deployment and reliable coordination. The German Bundeswehr, rebuilt in the 1950s, prioritized communications based specifically on these World War II lessons, ensuring every Leopard tank manufactured has carried comprehensive radio systems. A Bundeswehr training manual explicitly states that the defeat of superior German tanks by inferior American vehicles with superior radios teaches you that information dominance outweighs platform superiority. Modern conflicts continue to validate this lesson for you. In the 1991 Gulf War, coalition forces with superior communications destroyed Iraqi forces equipped with individually superior Soviet-designed tanks, but inferior radios. By 2003, American forces again demonstrated that network-centric warfare effectively defeats platform-centric warfare. The story of American Sherman tank radio superiority represents a victory in the electromagnetic spectrum that proved more decisive than advantages in armor or firepower. You must realize that German tank crews fought their war partially blind to this revolution, discovering too late that every Sherman tank was not just a fighting vehicle, but a node in history's first battlefield network. The SCR-508 radio transformed the M4 Sherman from an adequate medium tank into a vital component of a weapons system that included every other American tank on the battlefield. This transformation proved more decisive than any improvement in armor or firepower could have achieved. Every Sherman tank carried the tools of victory, not just in its 75mm gun or sloped armor, but in the 181 pounds of radio equipment that connected its crew to every other American tank crew. This connection created a collective intelligence that no individual German tank, regardless of its superiority in armor or firepower, could match. German forces discovered this reality through bitter experience at Kasserine Pass, in Italy's mountains, across France's hedgerows, and in Germany's final battles. American tanks demonstrated a level of coordination that German doctrine said was impossible without visual contact, and the Wehrmacht never developed an effective counter because they never fully understood the technological gap. Field Marshal Wilhelm Keitel's reported comment at Germany's surrender, "We knew how to build better tanks, but you knew how to make them work together," captured a fundamental truth, whether accurate or apocryphal. America had built not just 49,324 Sherman tanks, but 49,324 nodes in the world's first armored battlefield network. The revolution in military affairs that historians identify with modern network-centric warfare actually began in 1942, when the first Sherman tank with an SCR-508 radio entered combat. From that moment, warfare changed forever. The side with superior communications would defeat the side with superior weapons. The network would defeat the platform, and the connected would overcome the isolated. Yet, this transformation occurred largely invisible to German forces. They saw American tactical superiority, but didn't recognize its technological foundation until far too late. By the time German commanders understood that every Sherman tank possessed communication capabilities that most German tanks lacked, the war was effectively decided. The German military's failure to recognize and adapt to American communication superiority stands as one of World War II's great intelligence failures. Despite countless battlefield encounters demonstrating American coordination advantages, German leadership never prioritized solving their critical communication weakness. They continued building superior tanks that fought as isolated individuals, while American forces built adequate tanks that fought as coordinated teams. In the end, the electromagnetic waves carried by SCR-508 radios proved more powerful than the armor-piercing rounds fired by German 88mm guns. The ability to coordinate, to share information instantly, to fight as a unified force rather than as individual vehicles, this invisible advantage determined victory more surely than any visible superiority in armor or armament. The Sherman tank's radio superiority changed warfare forever, establishing the principle that, in modern combat, connection equals survival and isolation equals defeat. German troops discovered this reality on battlefields across 3 continents, learning too late that the Americans possessed not just numerical superiority, but technological superiority in the dimension that mattered most: the ability to fight as one.